Assuming you've completed the film calibration step, I'm going to show how to calculate a dose map using the EBT3 Rapid Arc example included in the FilmQAPro installation package. The route is shown on the screen. With the calibration object in place and completed, the next step is to add a dose map object. So click on the line Add New Case Object under Case Object Management at the bottom of the case tree. Pull out the menu and select Dose Map Single Scan. After the Dose Map Single Scan object appears in the case tree, click the plus sign to expand the dose map object. To introduce a dose map film, right-click on the first line of the object. There are two ways to add a film image. Either scan a film to obtain the desired image, or, as in this case, to load the image from file. To start, I'll demonstrate generation of a regular dose map, but I'm also going to show how to calculate a dose map using the reference strips in the image you've just loaded, together with the one-scan dosimetry protocol. So navigate to the example EBT3 Rapid Arc folder and load the file dosefilm0_313.tiff. The 0 and 313 embedded in the file name are the dose values in centigrade for the reference film, and you'll need them later. The principles behind the one-scan protocol are contained in the medical physics article referenced on the slide. Since the case already contains a calibration, as soon as the dose film image is loaded, calculations begin using the triple channel method. The theory and mathematics behind multi-channel radiochromic film dosimetry has been published in medical physics as referenced on the slide. Since most images have at least hundreds of thousands of pixels, there are a lot of optimization problems to solve in completing the multi-channel dosimetry calculations. Depending on your computer system, this may take anywhere from a few seconds to a half a minute, during which time the little star in the lower right-hand corner of the screen will turn blue to indicate the process is underway. And if a case tree has multiple dose map objects, there could be multiple calculation tasks in process, as indicated by the numeral next to the star. When the calculations are done, the dose map appears as a thumbnail on the branch just below the dose film. And below that, there is a thumbnail image showing a consistency map. This map shows the correspondence of the calculated dose values in the three color channels. Essentially, it is a map of dose uncertainty, and ideally, all three dose values should be the same. For now, click on the thumbnail image of the dose map. We'll return to the consistency map later. The dose map should now show in the image window. Let's begin by looking at the dose values of the reference films. They should be 0 and 313 centigrade. To do that, click on the frame selection tool. It's the icon at the top of the toolbar in the image window, and draw a region of interest frames in the center of the reference films. Then click the Statistics tab. It's the third tab down in the Analysis window, and a table of dose values appears. The first two columns of the table show values near the cursor and in the whole image, but ignore them for a moment and look at the values in frames 1 and 2. Values for frame 1 are close to 0 in each color channel, and for frame 2, the values should be close to 310 centigrade. The differences between measured and expected values are the result of scan-to-scan variability, perhaps due to the scanner itself, or perhaps due to temperature differences between the time the calibration films were scanned and the time the dose films and reference films were scanned. But if you stop right here, you've accepted a 1% offset in your dose map. So let's see what can be done to eliminate it. This is where the one-scan protocol can be applied. As I mentioned before, the principles have been published in medical physics. We'll begin by right-clicking on one of the regions of interest on the reference films and designating that ROI as a calibration region. Notice that the frame changes color as I do that to indicate it's now a calibration region. Right-click again on the frame and choose Calibration Value from the menu. The first calibration region is on the unexposed film, so the dose is 0. Type in the 0 value when the calibration value panel appears, and then hit Enter and OK to accept the value. Now repeat the process for the exposed reference strip and the reference dose of 313 centigrade, making sure that the dose value has the right units. Now right-click on the top line of the dose map object, just where it says Dose Map Single Scan. And from the context menu, select Dose Mapping Method, then Recalibration using Reference Regions, and Dose Linear Scaling. Return to right-click once more on the top line of the dose map object and select Rebuild Dose Map. Again, the blue star in the lower right corner of the analysis window shows that the calculation task is in progress. Calculations might take from a few seconds to half a minute, depending on the image size and the computer hardware. And upon completion, the thumbnail images of the dose and consistency maps are refreshed. Click the dose map thumbnail to display it in the image window, and then click the Statistics tab to look at the dose values in the reference films. The exposed film is now exactly 313 centigrade in each color channel. For the unexposed film, the displayed values are not quite 0, but this is only because FilmQAPro doesn't recognize negative dose values, and any negative value from the calculation is set to 0, but statistically, the values are correct. The dose map is ready to use. Right-click the thumbnail to save it as an image, or use the image export icon on the toolbar to export a table of comma-separated values to another application. Any film or dose map image can be saved or exported as a 3-channel image, or files can be created from any of the channels individually. With the dose map calculation complete, let's take a quick look at one of the useful data displays. A dose profile across any selected path on the dose map can be displayed in the analysis window. Do this by using the Profile tab in the analysis window and clicking the Profile tool icon on the toolbar along the left edge of the image window. You can select from vertical, horizontal, diagonal, circular profiles, etc., and then use the mouse and cursor to specify the path to be profiled. After drawing the profile line, click again on the profile icon or on the line to select the width over which averaging occurs.